When we have a quadratic sequence, which is a sequence where the second differences are constant, we have a formula, Tn, the general term, the nth term, which will have a structure that looks like a quadratic, an squared plus bn plus c. Now, its usefulness is so that we can work out, for example, which one number is the 52nd term, or the 103rd term, or what have you. We can find out what that term is straight away, going directly to it. We don't need to find all the other terms beforehand. So it's a useful thing to have. So in terms of how we get our full formula, i.e. what values of a, b and c are going to go in there, so that we get this formula, there's a process that you have to go through, and I'm going to explain that now. So the first thing to do is just to look at the sequence, to actually come up with what's going on with the sequence. So from 4 to 7, we're adding 3. From 7 to 12, we're adding 5. From 12 to 19, we're adding 7. From 19 to 28, we're adding 9. So we can see here our first level differences aren't constant, so we know this is not a linear sequence. So we then say, well, we smell her out. We can sense there's something going on here. So we now look at the first differences and see what happening with those. So as we go from 3 to 5, what's going on? We're adding 2. From 5 to 7, we're adding 2, and from 7 to 9, we're adding 2. So we can see that our second level differences are constant. So we've confirmed to ourselves that it definitely is a quadratic sequence. Now we need to work out what our an squared plus bn plus c expression actually is. And the first step is a bit of a rule that you just have to know. Okay? And we have a is going to be whatever the second level difference, we just halve our answer, which is divide by 2. So in this instance it's 2 divided by 2, which is 1. Okay, this gives us a reasonably decent situation. So we know straight off that we've got Tn is equal to 1n squared plus bn plus c. And the key thing to appreciate is we've got the squared bit, the 1n squared, and we've also got this bit here, this bn plus c. That's basically a linear sequence expression. So what I'm saying to you here is this: my sequence, the 4, 7, 12, 19, 28, this sequence is actually made up of a square bit and a linear bit. So if we can work out what those two sections are, then we can actually break it down. So we know that part of it is the 1n squared. So let's just write out 1n squared. So, and when I'm talking about 1n squared, what I'm appreciating is what n is. N is the place. So the first term, the second term, the third term, the fourth term, and the fifth term. Okay, so for those places, what is 1n squared? So the first term, it's one lot of 1 squared. Then for the second term, we've got one lot of 2 squared, which is one lot of 4. And then we've got one lot of 3 squared, which is one lot of 9. Then one lot of 4 squared, which is one lot of 16, and one lot of 5 squared, which is one lot of 25. So what we've gone so far is we just worked out 1n squared. We don't know what bn plus c is, but we can work that out in a second. Okay, the key thing is 1n squared is represented by 1, 4, 9, 16, 25. So my sequence here can be broken up into that 1n squared bit and also the linear bit. So let's just go through that and do the linear bit. Bn plus c. What's bn plus c? Well, what do I add on to that 1 to get 4? Well, I add 3. What do I do to 4 to get 7? I add 3. What do I add to 9 to get 12? I add 3. And you can see there's actually a theme going on, because it's the same for what you add on to 16 to get 19 and 25 to get 28. So this is a rather special case to a certain extent, because what it represents is there's no actual linear bit where it's going up by a certain amount each time. It just seems to be a constant. Okay, so how do I understand what's going on with bn plus c? Well, the bn is actually not doing anything because it's not going up by each time, so the difference is 0. Okay, so there's no bn, but the constant c is 3. So overall, we have Tn is equal to 1n squared, there's no n's, and it's plus 3. And that's my Tn expression. And to use this formula, if I want to work out the 53rd term, I'm just going to put 53 into this formula. So 53 squared plus 3 gets me 2,812. And what I've not needed to do is go from 19 to 28, and then 28 onto another number, and then 28 out onto another number, another number, all the way up as far as the 53rd number. That's another sort of 48 other terms beyond to get to the 53rd term. Moving on to another sequence, if we have the numbers 9, 12, 19, and 30, what's going on with that sequence? So again, we just want to look at the differences. So this seems to be add 3, add 7, add 11. So the second level of differences, it seems to be add 4 and add 4. And the argument would be that the next one would also be add 4, so we'd have a first level difference of 15, and so our actual fifth term would be 45. So anyway, we've got our second differences is 4, so therefore we've got a constant second difference, so it's definitely quadratic, so it's definitely of that form Tn is equal to an squared plus bn plus c, and we can work out what a is because we can just take our second difference and halve it, divide by 2. Okay, so 4 divided by 2 is 2, so we know our sequence is actually going to be 2n squared plus bn plus c. And again, you got a squared bit and you got the linear bit. So let's just write out what that 2n squared actually is. So 2n squared, what's 2 lots of the square numbers? So we should know the square numbers are 1, 4, 9, 16, 25, 36, and so forth. So what's 2 lots of the square numbers? 2 lots of 1, 2 lots of 4, 2 lots of 9, 2 lots of 16. So that's our an squared, our 2n squared. We just now need to know what the bn plus c is. So we say to ourselves, right, okay, what do I add to 2 to make 9? What goes with 2 to make 9? Well, we have a situation where it happens to be plus 7. And what do we add to 8 to make 12? I.e., what goes with 8 to make 12? And the answer is we add 4. And what do we do with 18 to get 19? We add 1. And what do we do with 32 to get 30? We take away 2. So we have a situation where our sequence 9, 12, 19, 30, and 45 is made up of 2 plus 7, 8 plus 4, 18 plus 1, 32 minus 2. So let's now look at that sequence that we've got there. So what's happening when we go from minus 7 down to 4 down to 1 and down to minus 2? Each time we are taking away 3. So what we have here is basically inside this this linear sequence we have the minus 3 times table. So we could write that out. Minus 3 times table, minus 3n. So what is minus 3 lots of n? Minus 3 lots of 1, minus 3 lots of 2, minus 3 lots of 3, minus 3 lots of 4. And what do we go with minus 3 to get 7? Well, we have to add 10. And what do we have to do to minus 6 to get 4? We have to add 10. And what do I have to do to minus 9 to get 1? Add 10. What do I have to do to minus 12 to get minus 2? Add 10. So we soon realise that my sequence 9, 12, 19, 30, 45 is made up of three parts. It's made up from a squaredy bit, so it's 2, 8, 18, 32. It's made up of the minus 3 times table, and it's made up of the constant 10, such that 2 minus 3 and 10 make 9. 8 minus 6 and 10 make 12. 18 and minus 9 and 10 make 19. So in summary, we've got our Tn expression. It's 2n squared minus 3n plus 10.